In this video, you will learn how to identify the critical parts and how to graph a vertical ellipse. So let's look at a picture of an ellipse. The first thing I want you to notice is this long blue axis. The major axis is going to be the longest axis of the ellipse. If that is going up and down, vertical, you can tell that it's a vertical ellipse. The two blue dots on either end of the major axis are called the vertices. They are the endpoints of the major axis. Next, I'd like you to look at the green line. This shorter axis is called the minor axis, and its endpoints are called co-vertices. Next, let's look at the intersection of the major and minor axis. This orange dot is called our center. This is going to be HK, just like it was with the circle. The last thing we need to talk about are these purple points on the major axis. These are called the foci, which is plural for focus. You'll notice, just like with your parabola, the focus is inside the curve of essentially each parabola that connects together to make the ellipse. Let's now look at some different values. The length of the major axis is called twice of A. So from a vertice to the center, that's a length of A. That also happens to be the same length if you connected a focus with a co-vertice. The length of the minor axis is twice of B. And the length from the center to one of your foci is called C. Now we can find A and B very easily from our equation, as you'll see in a few minutes. But C, we need to have a formula for, similar to what you had for P in a parabola. So since the major and minor axis form a right angle, let's think about our Pythagorean theorem. Pythagorean theorem said that b squared, one of your sides, plus the other side, c squared, is going to equal the hypotenuse squared. Here, that's a squared. Now, if we wanted to solve for c, we would have to subtract b squared from each side. And that's going to give me the c squared equal to my a squared minus b squared. If I try to simplify this even more so that I have just c, I would have to take the square root of each side. And doing that, I'm going to have c equal to the square root of a squared minus b squared. This is the formula that we're going to use to be able to find c, which we will use to find our foci. So let's look at the equation on the next page. When we have an ellipse in the vertex form, you're going to notice that similar to a parabola and circle, your center is going to be HK. The H and the K are subtracted from the X and the Y value inside parentheses, which if you notice means that again you will need to have the opposite. Now another thing that we need to know is how do we figure out that this is a vertical ellipse if we don't have the picture? And that has to do with the denominators. A squared is always going to be the largest number for an ellipse. And so when the larger number is underneath y, you have a vertical ellipse, just like the y-axis is vertical. Next, let's talk about our vertices. Again, if I were to take the square root of a squared, I get a value of a. And so from my center, if I move vertically, so adding and subtracting a to the y value, I'm going to get my vertices. Now on the picture, this means we're going to move up and down, so the same direction of the major axis, a units. For my co-vertices, I need to take the square root of b squared. And here I want to move the other direction. So from the center, I'm going to add and subtract b. And that means on my graph, I want to move left and right, b units. Now again, c, we already have the equation for. That's a squared minus b squared. But we want to use that again to find our foci. Remember, the foci are on the major axis. So if we're vertical, I again need to move from my center, c units, vertically. So I need to add and subtract it to the k value. So again, I want to move c units up and down if we're vertical. Now that we have our definitions, let's look at a couple examples. So, first thing I would do, since these are not defined just as we did, is I would rewrite it so that it looks just like we did. Now, again, the larger denominator, 25, is underneath y. That's what's telling me I have a vertical ellipse. As far as my center, since nothing was added or subtracted to my x and my y, I know I'm at 0, 0. Just like with parabolas, as soon as you know your center, I would go ahead and graph that. Next, I need to look for my vertices. This, remember, comes from taking the square root of our a squared, which is always the larger number for an ellipse. And so here, the square root of 25 is 5. This means I have to move the same direction as my major axis, so vertical, up and down, 5 units. Then we want to name those. Next, I need co-vertices. This is going to come from taking the square root of b squared, so of our 4, and that's 2. That means I need to move the minor axis, so the other direction, horizontally, left and right, 2 units. And then again, name them for my chart. Next, before I can actually place the foci, I want to connect my vertices and my co-vertices. This gets rid of me accidentally connecting my foci and co-vertices instead of the vertices and co-vertices. Once I've done that, I can go ahead and calculate what C is going to be, which, remember, is our distance from the center to each focus. So if you remember, that's a squared minus b squared. So here, 25 minus 4 is going to give me 21. Now, since I cannot simplify the square root of 21, that's what I'll write for my length of C. And as far as the foci in my chart, to keep an exact value, if I start at 0 and add and subtract square root 21, I'm going to get our foci. Now, square root of 21 doesn't help me plot the points on the graph. And so in my calculator, I need to do the square root of 21 and get a decimal approximation. Here about 4.5. That tells me I need to move, again, the same direction as the major axis, so up and down, vertical, about 4.5 units. Once you've completed that, please pause the video and do example B on your own. Please now check your answer to example B. Again, because the 49 was the larger number in the denominator and it was underneath y, I have a vertical ellipse. My center was again 0, 0, and because the square root of 49 is 7, I had to move vertically from my center up and down 7 units to get my vertices. Because the square root of 16 is 4, I had to move from my center the other direction to get my co-vertices. Then, when I calculated a squared minus b squared, 49 minus 16, I got a square root of 33. Since square root of 33 does not simplify, that's what I used for the value of c in my chart. And again, because I'm vertical, I add and subtracted that value to my center. Now, to be able to plot that though, I needed to find the decimal approximation and move again from my center, the direction of the major axis, vertically, those units. Please now compare your answers with your partner, and then when you're done, do the examples on the next page.